200 meters below the surface. Open ocean. Nothing for thousands of kilometers in any direction. And then the water darkens. Not from clouds, not from depth, from something massive rising from below. A shadow the size of a building moving upward. Slow, deliberate. And then it opens its mouth. The jaws unhinge to nearly 90 degrees. The throat expands outward, accordion folds stretching wider, wider until the mouth becomes a cavern. 100 tons of water and krill rush in. A single gulp, the largest bite ever taken by any animal in the history of Earth. The blue whale closes its mouth. The tongue, weighing 4 tons, presses upward. Water floods out through baleen plates, and 500 kilograms of krill remain trapped inside. One mouthful, one moment, enough food to power a creature the size of a passenger jet. This is the blue whale, the largest animal to ever exist, larger than any dinosaur, larger than anything in 4 billion years of life on this planet. And almost nothing about how it exists makes sense.
Here's what should be impossible. An animal weighing 200 tons. That's heavier than 30 elephants, heavier than a Boeing 737. The blue whale's tongue alone weighs as much as an elephant. Its heart weighs 400 pounds, the size of a small car. But size creates problems that shouldn't be solvable. The larger you get, the harder it becomes to pump blood throughout your body. The heart must fight gravity, distance, the sheer volume of tissue demanding oxygen. Most large animals compensate with speed. An elephant's heart beats 30 times per minute. A human heart beats 60 to 100. A blue whale's heart beats 5 times per minute when diving. 5. Each contraction pumps 220 liters of blood through arteries so wide a human child could crawl through them. When the whale surfaces, the heart rate climbs to 25, maybe 37 beats. Then it dives again, and the heart slows back down, 5 beats per minute. This is the absolute edge of what's biologically possible. Any slower, and circulation fails. Any faster, and energy costs become unsustainable. The blue whale exists in a window measured in heartbeats, and that window is terrifyingly narrow. Then there's breathing. Blue whales hold their breath for 10 to 20 minutes, sometimes longer. When they surface, they don't gasp like drowning animals. They exhale in one explosive breath. A column of vapor 9 meters high, visible for kilometers. One breath. Then they dive again, plunging to depths where pressure would pulverize human lungs. But their lungs don't collapse. They compress. Air forced into reinforced airways that flex under tons of pressure without rupturing. It shouldn't work, but it does. The blue whale doesn't just survive at this size, it thrives, but only because every single system operates at the absolute limit of possibility. 1 degree off, and the whole thing fails.
For centuries, whalers thought blue whales were myths, stories told by drunk sailors, exaggerations, because nothing that large should exist. Then, in the 1800s, they started finding them. And when they did, they couldn't believe what they were seeing. Ships would spot the blow first, that towering spout of mist. Then the back would surface, and keep surfacing, meter after meter of gray-blue skin rolling through the water like a moving island. Some sailors thought they were looking at whales riding on the backs of larger whales. Others thought it was a trick of perspective. It wasn't. They were seeing a single animal, 25, sometimes 30 meters long. Longer than their ships, and the fear was immediate. Not because blue whales were aggressive, they weren't, but because something that massive, that powerful, moving through the ocean with no effort, was unnerving. Captains reported blue whales surfacing directly beside their vessels, so close the crew could touch them. The whales would exhale, and the mist would coat the deck in a fine spray that smelled like rot. Then they'd dive, and the water displacement would rock the ship. Some crews refused to hunt them, not out of mercy, out of superstition. You don't kill something that large. You don't anger the gods. But then the Industrial Revolution arrived, and superstition died with it. By the early 1900s, blue whales became the most valuable animals on Earth. Their blubber could be rendered into oil, tons of it, enough to light entire cities, lubricate factory machinery, and manufacture explosives. A single blue whale was worth a fortune. So the slaughter began. Whaling ships equipped with explosive harpoons, steam engines, and factory processing decks hunted them across every ocean. When a harpoon struck, it detonated inside the whale's body, tearing through organs, shattering bones. The whale didn't die quickly. It thrashed, it bled, it called out, low-frequency moans that carried for hundreds of kilometers underwater. Other blue whales heard those calls, and they learned. In some areas, entire populations began fleeing at the sound of ship engines. Mothers would position themselves between boats and their calves. Some would dive deep and stay down until their lungs screamed for air. But they couldn't outrun steam engines. They couldn't outlast explosive harpoons. By the mid-1900s, the killing had reached industrial scale. In the Antarctic alone, over 29,000 blue whales were killed in a single season. 29,000! The oceans turned red. Populations that once numbered in the hundreds of thousands collapsed to a few thousand. Some estimates suggest we killed over 360,000 blue whales in less than a century. It was one of the most catastrophic population crashes in history. And we did it for oil, for lamp fuel, for soap. When commercial whaling was finally banned in 1966, blue whale populations had nearly gone extinct. Some regions had fewer than 1,000 individuals left. They survived, barely. But the oceans they returned to were not the same ones their ancestors knew.
Now, here's the paradox that breaks every rule of predation. The largest animal on Earth doesn't hunt large prey. It doesn't chase seals or dolphins or giant squid. It eats krill, tiny shrimp-like crustaceans, each one smaller than your finger. A creature the size of a bus survives on prey the size of paper clips. This shouldn't work. Hunting small prey is wildly inefficient. The energy spent chasing and consuming tiny organisms should exceed the energy gained. For most predators, this equation is a death sentence. But blue whales solved it in one of the most extreme ways evolution has ever produced. They don't hunt individual krill. They hunt swarms, dense aggregations containing millions, sometimes billions of krill packed into small areas. When a blue whale detects a swarm, it accelerates, mouth opening wider than any predator in history. It plunges through the cloud, engulfing up to 100 tons of water and krill in a single mouthful. Then the magic happens. The throat has pleats, accordion-like folds that expand outward, turning the mouth into a massive trap. The whale becomes a living filter, sieving the ocean itself. Once full, the mouth closes. The tongue presses upward, forcing water out through baleen plates. The krill are trapped, the water escapes, the whale swallows. A single gulp can contain 500 kilograms of krill. During feeding season, a blue whale consumes up to 4 tons per day. 4 tons every single day. That's roughly 40 million individual krill. But here's the problem. Krill populations fluctuate wildly. Some years they're abundant. Other years they nearly disappear. Blue whales have no backup plan. They don't eat fish, they don't eat squid, just krill. If krill populations collapse, blue whales starve. It's the most specialized diet of any giant animal, and it's the most fragile. One bad year and entire populations can decline. 2 bad years and calves start dying. This is survival balanced on the edge of a single food source. And that source is disappearing. Here's something almost no one knows. Blue whales are the loudest animals on Earth. Their calls register at 188 decibels. A jet engine at full throttle is 140 decibels.
A rock concert peaks at 120. The blue whale produces sound energy thousands of times more powerful than anything humans can create without machinery. The calls are low frequency, deep pulses that vibrate through the water like earthquakes through stone. Some frequencies fall below the range of human hearing. We can't hear them, but we can feel them. Researchers standing on ships have described the sensation of blue whale calls passing through their bodies, a pressure in the chest, a vibration in the bones. It's not sound, it's force. But why so loud? Scientists believe the calls serve multiple purposes. Navigation. The whale sends out a pulse and listens for echoes, mapping underwater terrain across hundreds of kilometers. Communication. Blue whales are often solitary, swimming alone for weeks. Their calls allow them to maintain contact across vast distances. And mating. Males produce long, repetitive songs that can last 20 to 30 minutes, possibly attracting females or establishing territory. But here's the mystery. Blue whale calls are changing. Over the past 50 years, the frequency has been dropping. The calls are getting deeper, lower, more bass-heavy. No one knows why. Some scientists think it's a response to ocean noise. Shipping traffic, naval sonar, oil exploration have made the ocean unbearably loud. Maybe blue whales are adjusting, trying to be heard over the din. Others believe it's population-related. As numbers recover, maybe they don't need to call as loudly. Or maybe it's something else, something we haven't considered. The blue whale is speaking a language we're only beginning to understand, and the message is changing.
Here's what breaks you. When a blue whale calf is born, it's already one of the largest animals on the planet. 7 meters long, 3 tons, longer than most cars, heavier than 2 rhinos, and it's still growing. Fast. A blue whale calf gains 90 kilograms every single day, 200 pounds in 24 hours. By the time it's weaned at 7 months, it weighs 20 tons. How is this possible? Milk. But not like any milk you've ever imagined. Blue whale milk contains 35 to 50% fat. Human milk is 2%. Cow milk is 4%. Blue whale milk has the consistency of toothpaste. Thick, rich, packed with calories. A calf drinks 200 liters per day. That's more liquid than most humans consume in a month. And the mother? She's fasting, living off fat reserves built during months of feeding in polar waters. She's losing weight while the calf gains it, transferring energy directly from her body to her offspring. It's one of the most extreme acts of parental investment in nature. And it has to be, because blue whales are born in warm tropical waters where there's no food. They must grow fast enough to reach the cold, krill-rich feeding grounds before they starve. If they don't grow quickly, they die. There's no second chance. And once weaned, the calf is alone. No extended childhood, no years of learning. Figure it out or perish. Most don't make it. Calf mortality is high, though we don't know exact numbers because we see so little of their early lives. The ones that survive face years before reaching maturity. Females don't reproduce until they're 5 to 15 years old, and even then, they only give birth once every 2 to 3 years. Blue whale reproduction is slow, vulnerable, and entirely dependent on conditions being perfect. And conditions are rarely perfect.
Here's the thing no one talks about. Blue whales aren't invincible. Despite their size, they have predators. Orcas hunt them. Not often, but it happens. Pods of orcas working together can harass, injure, and kill blue whale calves. Adults are generally too large, too fast. But young whales, sick whales, injured whales are vulnerable. There are documented cases of orcas attacking blue whales for hours, targeting their fins, their flukes, biting until the whale weakens. Sometimes the blue whale escapes, sometimes it doesn't. But orcas aren't the real threat. We are. Ship strikes kill dozens of blue whales every year.
Massive cargo vessels moving at 20 knots don't see them, don't feel the impact. The whale's body is found days later, spine shattered, floating offshore. Ocean noise disrupts their navigation, their communication. Climate change is shifting krill populations, altering distributions, making food unpredictable. And pollution. Chemicals, plastics, toxins accumulating in their bodies, weakening immune systems, reducing fertility. Blue whales survived ice ages. They survived continental shifts. But they nearly didn't survive us. And the threats aren't over.
Scientists are only now beginning to understand what blue whales actually do. Satellite tagging has revealed migrations we didn't know existed. Some blue whales travel 10,000 kilometers between feeding and breeding grounds. Others stay in the same region year-round. There's no single pattern. Dive data shows they're going deeper than expected, sometimes exceeding 500 meters. Why? We don't know. Behavioral studies suggest they might have social structures more complex than we thought. Some whales appear to travel together for years. Others remain solitary. And then there's the question no one can answer. We've never observed blue whales mating. Not once. Despite decades of research, thousands of hours of observation, no one has witnessed it. The largest animal on Earth reproduces in secret. We don't know the behaviors, the rituals, the signals. It's as though they've hidden this part of their lives deliberately. Maybe they mate at depth, maybe at night, maybe so briefly it hasn't been captured. But the fact remains, we know almost nothing about one of the most fundamental aspects of their biology.
Nothing about blue whales is normal. Not their size, not their diet, not their reproduction. They are biological paradoxes, animals that shouldn't exist, but do. And they exist because everything is optimized for efficiency, efficient feeding, efficient movement, efficient energy use. Remove any one piece and the system collapses. They are perfectly balanced on the edge of impossibility. And that makes them fragile. Climate change is shifting their food. Noise is drowning their voices. Ships are turning migration routes into danger zones. Blue whales are resilient, but resilience has limits. For millions of years, they've existed as proof that life can scale to unimaginable sizes, that the largest doesn't need to be the fiercest or the fastest, just efficient enough, adaptable enough, lucky enough. We nearly erased them. We came within a few thousand individuals of making blue whales extinct forever. They survived, but they didn't survive unchanged. The oceans are louder, warmer, emptier, and the blue whale, for all its size, for all its power, is still just an animal trying to survive in a world we are remaking. Nothing about them is normal. They are extremes made flesh, proof that nature can push life to scales we can barely comprehend, and proof that even giants can be fragile. The blue whale doesn't follow rules, it rewrites them, and in doing so, it shows us that the limits of life are stranger and more beautiful than we ever imagined.
If you enjoyed learning about blue whales, we've created ocean-inspired wall art in the SeaScope collection. If you'd like to bring a piece of the ocean into your space, link in the description below. Thanks for watching, and we'll see you in the next video.